Good morning, everyone.
Good morning.
Is my screen and voice clear?
Yes, sir. Yes, sir.
CRs, kindly do note the absentee numbers. Na? CRs, are you there?
Yes, sir.
Yeah. So once the session is done, kindly do send me the absentee numbers.
So, yes, sir.
So the LMS Moodle team is working on automating the attendance and all these things. Na? So it will take some time. Also, there is some issue in getting the Zoom links as well. So previously in the past semesters, once the session is done, within 2 minutes, we used to get the link to our Gitam mails, direct the recording link, so that we used to share it in the GLAN or LMS Moodle. But there's still some issue with the recordings as well. So for every recording, we need to visit our zoom.us page in the website. We have to take that link and all. So there's some issues in Moodle with Zoom integration. All that will be sorted out soon. Okay. So I will share the sessions by this evening or by tomorrow evening. I will get all the links for the past 3 classes that has happened in the previous week, and I will share it in the Moodle. Okay. Yeah. So as you're all aware that the first module examination is going to happen from August 2nd. That is the next week itself. Okay. The timings is not fixed yet. So going by what is the time slot for your previous semester mid examination? Is it from 2 to 2:45 or 4 to 4:45?
Sir, it used to be 3 to 4, sir. 3 to 6.
Okay. 3 to 4. Okay. So then you used to be in second years, right?
Yes, sir.
Yeah. Okay. So no issue. We have all the sessions in the morning session. So hardly the morning session time won't be taken. Okay. So hoping, by the way, we have 6 sessions to go, but the problem is we need to cover roughly 8 to 9 topics. Okay. So I will be going at a bit pacey from the next unit onwards. That's not going to happen because of the introductory part. All the last week classes I have devoted to the introduction. Okay. Yeah. So I will be explaining you the concept, and I will be giving 1 or 2 examples to it. Okay. And do not expect me to discuss each and every possible problem for that concept, because time is a luxury to us. I cannot go on that path. As I have told you, flat is such a subject in which you need to practice. 40% of the effort is from the faculty to deliver the content to you. The rest 60% is up to the student fraternity itself. Okay, you are the one who needs to practice the concepts with as many possible examples as possible in order to get a solidarity on the concept. Okay, kindly do not expect me to discuss all the possible examples in the classroom environment itself. That's not at all feasible. Okay, so I will be explaining a concept and I will be giving 2 to 3 examples for each and every concept in order to have a better understanding. I will give all the questions set as well. I will upload the soft copy in the Moodle. So it's up to you to practice the things. Okay. If there is any issue in getting the solution and all, you can ask me in the classroom. I will just clarify the solutions, or you can mail or WhatsApp me also your answers. Okay. I will have a verification and I will revert back to you. But kindly do not expect the same in the classroom environment. Okay. Yeah. So in the previous session, we have discussed about the finite automata classification, right? Without output and with output. Did I discuss this classification, ma? Guys, are you there? 3B1.
No, sir, you didn't discuss.
Okay. So the entire finite automata, we will be dealing with the first module of our syllabus now. Okay. So the finite automata is divided into two categories, without output and with output. Without output, again, we have three classifications: DFA, NFA, epsilon NFA. And with output, we have two machines now, Moore machine and Mealy machine. So 1, 2, 3, 4, 5 concepts and some conversions as well. Okay. So how to convert NFA to DFA, how to convert epsilon NFA to NFA, Moore to Mealy, Mealy to Moore. So 5 concepts, 4 conversions. Hardly we have 9 concepts that has to be covered for unit 1. Okay. But try to cover all the subjects by the first module examination. Okay. So going by the classification, the first thing is deterministic finite automata. Simply DFA. So deterministic finite automata. So in the last session, we have discussed some basics of automata, right? It has 5 tuples, how to take the states, initial state, final state, all the basics that I have discussed in the previous session, that corresponds to DFA. Okay. So deterministic finite automata is a finite automata without output. Okay, this machine does not provide you any output, it only processes. Okay. Okay, and it is a deterministic machine. Okay, on one input, it reaches only one unique state. On one input, only one state. Okay, so that's why the name deterministic. The machine is very, very specific. Okay. So we have seen a basic automata machine, right? The initial state starts with an arrow brace. The states are labeled as Q0. So Q0 on 1, let's say it's going to Q1. Q1 on 0, it's going to Q2, which is the final state. Q1 on 0, it goes to, sorry, Q1 on 1, it goes to Q0. So this is a basic DFA we have seen. The initial state starts with an arrow brace. Final state starts with concentric circles. See this. One state on one input, it goes to a unique state. So Q0 on 1, Q1. Q1 on 0, it's going to Q2, but Q1 on 1, it's going to Q0. Okay, that's it. Output, I mean, input should be unique and the state should be different. So that is the property of deterministic finite automata. Okay, so it has 5 tuples. So what are the 5 tuples, ma? Anyone? What are the 5 tuples?
The
Q
states,
epsilon
Q sigma,
delta Q naught and F
what is Q?
states,
states.
So Q starts, I mean, stands for the states. What is sigma?
input,
Alphabet.
Alphabet of input. Delta,
transition
Transition
function,
function.
transition function. What is Q naught?
initial
Initial
state,
And what about F?
final state.
Final state. Yeah. So this is the basic DFA. It is a 5 tuple. It's without output. On one input, it reaches only one unique state. So that's why the name deterministic. Okay. So now the questions can be asked in 2 main methodologies. In DFA, the question can be asked in 2 methodologies. First, I will discuss the model one, which is very, very easy and very beautiful. If the examiner is an extremely good person and you are damn lucky, only then you will get some questions. So the model one is as follows. So here the examiner asks you to design a DFA. So design a DFA transition diagram. So design a DFA with TD. He gives the data. So Q ABC sigma 0, 1 Q naught A F is C, and the transition function delta is as follows: A comma 0 A comma 1 B. B comma 0 is C, B comma 1 is A, delta C comma 0 is B, delta C comma 1 is C. Now, this is the most easiest way of asking a question. See, all the data is given to you. It's just you need to study the data carefully and draw a transition diagram, right? Now, how many states are there for this DFA?
3.
So we have 3 states, right? Just observe the question. Q is for states A, B, C. So it is given that our DFA is having 3 states. Just draw the 3 states. So what are the state names now? A, B, and C. We'll discuss about the input and function later. Now we'll identify what is the initial state, which is the final state. Q naught A. Q naught is the initial state, right? So this is the initial state. F is C. So C is the final state. Just first label the states and determine which is the initial state and which is the final state. Now come to the function. A on 0 is A. What is the transition function of DFA? What is the delta for DFA? Q cross sigma is Q, right? This is the transition function that we have discussed for DFA. So for DFA, the transition function is of the form Q cross sigma is Q. That means from a state Q, if you take an input character, what is the state you are reaching? That is the notion. So this is Q A, this is sigma, input 0, and this is a new state A. So from state A, if you take 0, you will reach A. This is what he has given. So from state A, if you take input 0, you will reach the same state A. Got it, all of you?
Yes, sir. What?
Now, A on 1 is B. So from A, if you take the input 1, you will reach a state B. So A on 1 is B. The directions are very, very important. Just don't draw simple lines. The directions is very, very important. Okay, now come here. B on 0 is C. So B on 0 is C. B on 1 is A. So B on 1, it goes back to A. C on 0 is B. So C on 0, it again goes back to B. C on 1 is C. So C on 1 goes to C. That's it. Okay. So this is the first model of questioning. You are asked to draw a transition diagram wherein all the data is given. The 5 tuples are given. So Q, sigma, Q naught, F, the delta part. All the data is in front of you. Just make it into a transition diagram. Okay. Clear, all of you?
Yes. Say what is deterministic finite automata?
I didn't get your question clearly.
What is meant by deterministic finite automata?
See this machine. See B on 0, it's going to C, right?
Yes.
B on 0, it's going to C. B on 1, it is going to A. Different input, different states.
Yes.
This is what called as determinism. Don't worry, in the next topic, I can show you the difference between DFA and NFA. Okay, just this is what the determinism is. From a state on a single input, you are reaching a new state. Not that from 0, you are not, beyond 0 is again a new state D. This is not the case of DFA. On an input from a state, you should be reaching one unique state. That's what the determinism is. Got it?
Yes, sir.
Yeah. So this is the first model. Next, model 2. The same other way around. This transition diagram is given directly and you are asked to write the 5 tuples. So for this diagram, what is Q? What is sigma? what is delta, what is Q naught, what is F. Okay. Guys, clear?
Yes.
I hope you
Yes,
can construct the both ways around. Given a data, I hope you are very clear that constructing a machine, and if the machine TD is given, you can able to infer the 5 tuples from this given diagram. So these are the two basic models of questioning in the DFA. Okay. Now, the third model, which is very, very important. This is the one that is asked more frequently. So model 3. So DFA as a language acceptor. Okay. So I have said that DFA is a machine that does not have any output. So it is not a common input processing output kind of machine. Then you can ask me, sir, if it's not having an output, what is the exact task of that machine? What is the main application of the DFA? So the main application of the DFA is language acceptor. So it scans an input and checks whether it is belong to that machine or not. Okay, I will explain you. So the other way of questioning is like this one: design a DFA. Okay, not all the tuples are given, only the input alphabet is given. So design a DFA over the alphabet 0, 1. Okay, only sigma is given, Q, Q naught, F, all such things are not given, even the transition functions also. Okay, so design a DFA over the alphabet 0, 1 such that the language is, he specifies the constraint here, such that the language should be starts with 1, ends with 0. Okay, this is the constraint he gives. Okay, so design a DFA over an alphabet epsilon sigma, which is 0, 1, such that the strings or the language starts with 1 and ends with 0. So the machine should accept all possible strings of this criteria 1 and 0. So 1, 0, 1, 0, 0, 1, 0, 1, 0, 1, 1, 0, all possible combinations. Starting with 1, ending with 0. 1, 0, 1, 0, 1, 0. Okay. The first character is 1, the last character should be 0. There's no restriction on the middle. It can have as many zeros and as many ones in the middle position, but the starting and ending should be like this. So this is how the constraint is. Okay. So the most of the questions, it will be asked in this fashion. Okay. Design a DFA over an alphabet 0, 1 such that it accepts all the strings that starts with 1 and ends with 0. Okay. Now, for such language acceptor questions, what you need to do is, first step 1, find the minimum length of the string or minimum strings length. Now, what is this minimum string or minimum string length? Now, starts with 1, ends with 0. For this criteria, what is the basic string? This is the string, right?
Yes.
Starting with 1, ending with 0. This is the most basic representation of my criteria, right? I'm not talking about the mid constraint. This is the least possible string, right?
Yes, sir.
What is the length of the string?
2.
2. So find the minimum string for a criteria. Find the minimum string length. What is the length? 2. So the notion is the number of states of a DFA. Number of states of DFA is n plus 1, where n is the length of the minimum string. Okay. So this is the notion. First, find the minimum string length. This is n. The number of states your DFA should be having is n plus 1. This is the minimum state DFA. This is called as minimal state DFA. Okay. You can take 4 or 5 states also, that's not an issue, but the minimum you can take is 3. So here in my case, the length of the string is 2. So the number of states is 3, 2 plus 1. So minimum you should be taking 3 states for this DFA. That's how you will determine on the count of the states. Okay, got it all of you?
Yes, sir.
So for such language acceptor questions, first train the minimum string. What is the criteria that the examiner is asking? What is the least string that I can have? For example, over the alphabet A comma B, all the strings ends with AB. So BAB, AAB, AAAB, all the strings. So, but the least string is AB, right? So here also the length is 2. So the DFA should have 3 states. For example, over the alphabet 1 comma 0, he wants all the strings ending with 101. So 101 is the least string. 0101, 1101, 1001. Sorry, 10101. All the strings can be anything, but the least is 3. So here you have 4 states. Okay. So for such problems, always determine the minimum string. For the criteria, what is the minimum string length? So here the criteria starts with 1, ends with 0. So starts with 1, ends with 0. Length is 2. I have applied the modulus. That's it. Just for your understanding. So my length is 2. This is n. Now what is my formula? The number of minimal states of a DFA is n plus 1, where n is the length of the minimum string. So here in my case, length of the minimum string is 2. So my number of states is 3. So take 3 states. Now, how to name the states? So always follow the lowercase alphabet Q. If in the question, for example, the examiner has used some other notion, then it's fine. You can have A, B like this. For example, A on 0 is B, B on 2 is C, like this. If the question is given like this, you can take the same names. If the question is not given, I mean, if the constraints are not specified regarding the naming, always take the lowercase alphabet Q0 as the first statement. This is the standard notion. Okay. Our aim is to get good marks in the subject, not to show your like what say the understanding and your depth of the subject. Okay. Your main aim is to get a good score in the subject. That's it. So kindly don't show your subject's domain at the examination level itself. Kindly do not take some fancy naming schema and all, because all the examiners that who are evaluating your scripts, they are of the notion, because from the age-old standards onwards, this is the standard notion. Q0, Q1 and Q2, wherein Q0 will be the initial state. Okay, so kindly don't play other way around. It's for your own good. Okay. So in the question, if the examiner has himself hinted different names, kindly follow that notion. Else, for such kind of general questions, always your state name should follow with the Q notation. So my states are Q0, Q1 and Q2. Now you need to design the state machine. So while designing the machine, always start with the least possible string. What is my least string? 1 and 0, right? So from Q0, let me change the ink. So from Q0, I'll take 1. I reach the state Q1. Again from Q0, I take the input 0. I reach the Q2, which will be my final state. Got it, all of you? Yeah. So this machine is accepting 1, 0. Now what about 1, 0, 0? My machine should not only accept a single string. I want a machine that accepts all the strings, starts with and ends with 0. So 1, 0, 0 is also such string. It's in the same language library, starting with 1, ending with 0, but it has a 0 middle, 0 in the middle, right? Now, based on the upcoming strings, kindly do edit the DFA. Okay. First, develop the machine. I mean, first develop the finite automata with the least possible string. Then you can add on automata based on the upcoming strings. Now, 1, 0, 0. If my machine needs to accept 1, 0, 0, I can have a 0 here, right? Now my machine is accepting 1, 0, 0. Agreed?
Yes, sir.
Now take 1010. So a machine need to accept this string 1010. What is the modification I should do, ma?
Zero and Q0.
1010. It's already, I mean, the machine is already good for 100. There should be one in between. Think in that fashion.
Sir, maybe we'll add one more state.
No need of other state. See this. One zero, again 1 0. Satisfied?
Sir, but how we can be sure that from Q2 to Q1 it will require one?
Because there is a string that should accept 1010, right?
Sir, but
10,
Q2 is
10,
the final statement, sir.
Come
Can
again?
we come back? Q2 is the final statement, sir. Can we come back again?
Q2 is a final state. Okay, you are coming back to Q1. Again from Q1, what is that you are taking?
Again, Q2 we are taking.
You are ultimately reaching the final state, right? Then what's the issue? You are not stuck in the midway. See, ma, the question
Sir,
is, I mean, the
so, like-
constraint is for every string at the end, you should be reaching the final state. So 10, final state, fine. 100. So 10, again 0. From final state, if you are not, I mean, coming back to that final state, then it's going to be an issue. So for 100, again, you are reaching the final state. Fine. 1010. So 10, I'm with the help of this input 1, I'm coming to Q1. Again with this 0, I'm reaching to Q2. So 1010 is also fine.
Sir,
Yeah, what's your doubt,
like,
ma?
Sir, so like, is it dependent on our wish, like wherever you want to keep the arrows?
No, not our wish, ma. What's your name?
Atharva, sir.
Atharva.
Yes,
I'm
sir.
designing this machine based on the constraint given. My constraint is it should start with 1, ends with 0. I have told you, right? Nothing wrong, nothing right, nothing optimal, nothing unoptimal. You can modify the DFA, but ultimately the meaning should not be altered. Now see this 110. My machine should accept string 110. This also starts with 1, ends with 0, right? Now 1 with 0, I'm directly reaching the final state. I should have a 1 in between. So from Q1, I will make a 1. So 110. Got it?
Okay, sir.
Yes.
Now this machine will accept all the strings that starts with 1 and ends with 0. Whatever be the like mid-level configuration. How many zeros or how many ones you take, it will reach, no issue. Okay, ma? Guys, understood?
Yes, sir.
Yes.
So DFA as a language acceptor, this is the most important model. The questions are asked in this format. Okay, you will be given an alphabet and a constraint. That's it. So what you need to do is based on the constraint, just write all the possible strings. But your aim is to check the least possible string or the minimum length string, find its length, add 1 to it. That will be your minimum states. As someone is saying, I have taken 3 states because it's a minimal state DFA. Sometimes the examiner will ask you to write a minimal state DFA. If not, you can take 4 or 5 states also. That's not an issue, not a problem. It's not wrong either. As one of your classmates is suggesting, you can take one more state, you can have one input 1 or 0 or whatever, no issue. But the question is, I mean, the notion is minimum I require 3 states, not less than 3. I can go with this problem. It's the formula. Okay. The scientists upon years of research, they have discovered this truth. So if my length of the string, minimum length string is 2, I should have minimum 3 states now. Only then the solution is feasible. You can have for 4 and 5 also, but that's not an issue.
Sir, for if this kind of question is asked, so to answer this question, how many diagrams you have to make?
It's up to you, other. The time factor and all this plays a key role. But this one is enough. You can have a minimal state DFA, one representation is fine. But check that whether your machine is valid or not. If he asks starts
Okay,
with
so
one,
even
ends with
one
zero.
even one diagram will fetch the result, right?
Yeah, if the DFA is
Okay.
correct, if it is yielding the strings, then it's fine. But if it starts with one, ends with zero, that's what asked. Kindly do not make a machine like this. Starts with zero and ends with one. This is wrong. Okay. Your machine should be valid. That's it. How many states you are taking, how many paths, that doesn't matter. Your DFA should be valid.
So what about 1110, sir? How can you do that?
1110.
Yes, sir.
So 1. So for this 1110, you need to alter a bit.
Yes, sir.
So
So
you have to
weren't
take
we
a new
supposed
state.
to make one for which valids for everything, or I mean, I didn't get that part, sir. It should be valid for every string.
It's not possible to make a machine that accepts all possible strings. But I mean, for this example, see 1110 is not feasible
Yes,
with this
sir.
machine.
Yes, sir.
So, but most of the first three cases it has satisfied, right?
Yes, sir.
Yeah. So it is fine if it is accepting most of the cases.
Sir, we can still make 1110, no sir. At Q0, if we take input as 1 and like Q1 also, if we take 1, it will still be 1110, no sir. Yeah, there 1 and
Yeah,
1110.
1110. No. See, this is not altering the meaning of DFA. From Q0 on 1, you should reach a new state. You should not go back to like this.
Okay.
That is NFA. That will make this diagram NFA, not DFA.
Yes, sir.
Okay.
Sir, so
Yeah.
so for example, for 1110, from Q0 to Q1 we go, and then again take a 1 at Q1.
It's fetching me 2 ones.
Yes, sir. You can't go back the third time. Okay.
Can't go back.
Like for example, Q0 to Q1 and then to Q1 again. Can I again go to Q1 again?
1 second. 1.
From here we
from
have
Q1.
to from here, sir, we have to compulsorily go to Q2, or can we again take 1 as input?
In DFA, you can have more than one final state. Wait, let me show you
So
another
what
example.
she meant was from Q0 to Q1 we went. So like we again come back to Q1 also. Can we do that again? Like again
Yes.
from Q1 to again Q1 2 times.
Again,
that
with the help
part.
of 1, you can come back here to Q1, right?
Then
Yes,
we'll
sir.
get 1110.
1110. That's what she meant. Can we do
1.
that?
1.
Sir,
Yeah, 10.
and then 1 again. And then we go to 0 as we are reaching at the final state.
Yeah, sorry. 1 second. Yeah. 1. You can take as many ones as possible. 1, 1, 2 ones, again 0. That's also fine.
Yes,
So
sir.
it's,
Yeah.
Got it?
Yes, sir.
So 1, let's say 3 zeros, 0. So 1, 0. You can have as many zeros as you wish, but the ends with 0. Fine.
So we can take as many as inputs there.
Yeah, that's up to you. This machine will give all the strings that starts with 1, ends with 0, and whatever be the combination of 1, 0 in between. So this is the regular expression of this machine, I would say. 1, 0, this is basic one. So as many iterations you can take. So previously she has asked a 1110. Yeah, I haven't seen this in this way. So 1, 1, I can take one more 1. I will take the 0 and reach the final states. Your constraint should be such that you should be reaching the final state. Okay. One second more. Let me discuss one more question. With this, you can have some clarity. So design a DFA over the alphabet A, single character, such that my language is A, 3S, 5A, and 7A. So the first 4 odd powers of A, my machine should accept. So A power 1, A power 3, A power 5, and A power 7. Now for this, you require 2 final states. So for this DFA, you require 2 final states. What is the minimum length of the string, ma?
3, sir.
3.
Oh,
Why 3?
1.
1, sir. 1, sir.
1. So minimum length is 1. What will be the states?
2 states.
2.
2 states.
2 states.
So let's start with the 2 states. So Q0 and Q1. What is the input? A. It is final state. Fine. Now, in order to make this machine accept 3 A's, what I should do?
So we can put 1A at Q0. We can put 1A at Q1.
Q1 you can put another A, sir.
A. Right?
Yes, sir.
What about 5 A's?
So
Then, I mean,
Q1,
at final state, you can do A again and again. So you can repeat it.
Right?
Yes,
So this
sir.
is a minimal state DFA. What if the examiner asks you to have 2 final states? Your DFA should be having 2 final states. This is 1 final state, right?
Sir, from
Yeah,
from Q0 we can make another.
So Q0 on A, it is going to Q1, which is a final statement. This is fine. So if he wants 2 final states, what you can do is, for 3 A's, I am showing you, see. A. It is good for 3 A's, right? So even for 3 A's also, we are not going for a new final statement. But what is the case of 5 A's?
Same, sir.
Same. You will keep an A here. But that's not the case. This is a DFA. You should not put A loop here if you have used this. So A, 3 A's.
4
You
and
can
5
go on
also
forever,
going on.
but what about 2 final state? That's my question. So see this, so Q0, A, Q1, which is a final state. So A, it is good for 3 A's. So in the case of 5 A's, what I will do is, I will have one more state. I will have one more state, which will be the new final state. So if this is the case, I will remove this A. Now this is good for 1A. This is good for 3 A's. Now what about 5A? 1, 2, 3. From final state, I need to have something, right? So Q4 on A. Q4 I will link to Q1. It is getting me 5 A's, right? 1, 2, 3. From Q3, I take 1A, reach Q4. Again from Q4, I take 1A, I will reach Q1, which is also the final state. Now got it?
Sir,
Sir,
in
so
the
is it our
earlier,
wish that wherever we can place final state?
Yeah, but the meaning should not be altered, ma. That's very important.
sir, in the earlier one, why can't like we can go from Q0 to Q1 again, Q1 to Q0 again, Q0 to Q1. Can't we repeat that cycle, sir?
This one or this
No,
one?
the right sir, that one, sir.
This one.
Yes, sir. Then we can get 5 A's. Q0 to
A, 2, 3, 4, 5. That's
yes, sir.
this is a valid method, but I am saying if I had meant a
Okay,
constraint that 2 final
okay,
states.
sir. Okay, sir. Oh,
That's why I have told you these 3 versions, ma.
okay, sir.
Every DFA is valid, every DFA is authentic. This is also fine, this is fine, this is also fine. It all based on the constraints. If the examiner want to trouble you a little bit, he goes on like this. I want final states, I want 7 final states in my DFA. So the problem will be much more complex. It will take up hardly 7 to 8 sheets of your answer sheet in the SEM and examination. Okay. So based on the constraint, you need to alter the machine. That's what I'm saying. No DFA is right, no DFA is wrong. This one also gives me, satisfies my constraint. This one also satisfies my constraint. This one also will follow my constraint. But based on the 2 final states, if the 2 final states are asked, you have to go with this one. If that is not the case, you can go with either of this. But check for DFA from one state, from on one input, it would go to only one state. So for example, if I make Q1 to A here, this is not DFA. Because Q1 on A, it is going to Q2, it cannot go to Q0. This is not a DFA. This will make me NDFA, which that will be discussed in the next session. Okay.
Sir, we can have as many as states to final states.
Come
That
again?
means, we can have as many as states to final states. Like here Q1 and Q3 are final states. So you have taken another 2 states, sir, extra 2 states, Q2 and Q4. So we can make as many as states.
DFA can have multiple final states. That's the one leverage we had with the DFA. Okay, you can note this point. DFA can have multiple final states. Okay. That's it you're asking.
Sir, but the number of states should be 2, no, sir?
Baba, that is the case of minimal state DFA. Rule kaadu alane teesukovalani em ledu. We can go other way around also.
Oh, okay, sir.
Just in order to start the process, just to have a bare understanding of how many states should I take, this is the notion. మీరు minimum length చూడకుండా కూడా మీరు డ్రా చేసుకుంటూ వెళ్ళిపోవచ్చు. Got it? Not
yes,
that
sir.
always this criteria is, should be followed. But this is just a blind thumb rule. That's it. How to start the proceedings. You should have a number of the states, right? In order for this is the notion. Not that every time this needs to be used. The moment if I say multiple final states, this will null and void. See, because it has given me a total of 5 states, of which 2 are final states. Okay. Not that each and every time this criteria needs to be satisfied. This is just a base rule on which you can start your proceeding. That's it. If the examiner is specifying some constraint, no need to worry about the other constraints. You just concentrate on your DFA, whether my DFA is satisfying the constraint specified or not. That's it. Okay.
Yes, sir.
So by the evening, I will upload you a soft copy of